Good morning, dear students. How are you all? In the today's session, we will discuss regarding types of overlapping. In last class, also we discussed regarding the overlapping itself. We just brief it off by considering how exactly overlapping takes place, and then we will move to the next part. Listen to me very properly. If you consider overlapping, there are mainly of three types are existed. The first one is said to be SS overlapping, second one is SP overlapping, and the third one is PP overlapping. When you consider SS overlapping, it is means that we will be having two orbitals, S orbitals, their electron cloud is going to merge each other. It is going to penetrate each other. We know that S orbital has nucleus and it is surrounded by spherically with the electron cloud. We can also say electron cloud is symmetrically distributed around the nucleus. That type, those orbitals are considered as S orbitals. When you consider both the same type of orbitals where electron cloud is symmetrically distributed, that type of overlapping is called as SS overlapping. So these two what I have written here are referred as atomic orbitals. Atomic orbitals will be combining each other. They will combine each other in such a manner that there will be a overlapping can be seen. Penetration of electron cloud of two atomic orbitals can be seen. It is referred as SS overlapping. When both the phases of orbitals are same, then we can consider there will be a bond formation going to happen. Similarly, listen to me, I have SP overlapping. As I already told you, S orbitals are symmetrically distributed with the electrons. But when you consider P orbitals are not symmetrically distributed. We know that there is a shape of a molecule, shape of a P orbital, it is dumbbell shape. There will be dumbbell shape is present. And we have Px dumbbell shape, Py, Pz also dumbbell shape. Then we have d orbitals, they are said to be double dumbbell shape. These things we have dealt in detail in the chapter atomic structure. We have done there. Okay. Now coming to the next one, sp orbital, that is I mean to say sp overlapping. I have s orbital present here. Okay. It is going to be combined with p orbital. It is going to combine with p orbital. So here also we must have to have the same phase according to Schrodinger wave equation. We have done here that wave function. We have done wave function. According to that, these signs what I have written are said to be phases. When same phases are present in the orbitals, then there is a possibility of bond formation. So s orbital combined with, this is s overlapping. Here this is said to be sp overlapping. They combine each other in such a manner that overlapping is seen in this fashion. Here the whatever the lines I am darkening here is said to be overlapping area, overlapping of the electron cloud. Similarly, I have third category, that is PP overlapping. We know that whenever we consider PP overlapping, we must have to have two p orbitals. Say for example, both the p orbitals may have head-on overlapping or they may have sideways overlapping also. Okay. Generally, PP orbitals will be having head-on overlapping as well as axial overlapping. Interaxial, this is said to be internuclear axis. When they combining in this fashion, we can consider head-on overlapping. Here also we must have to have same phase, right? This side we can consider the other phase, right? So here overlapping is seen in this fashion. It is seen in this fashion. So this is PP axial overlapping. Likewise, we also have sideways overlapping. This is axial overlapping. Axial overlapping. Likewise, we have sideways overlapping is also possible. Generally we see in PP overlapping, it is sideways overlapping only we generally consider. See here, this is said to be p orbital. Similarly, I have one more p orbital is combined in this fashion. Initially these two p orbitals are like this. Okay, this is plus, plus, minus, minus. After combination, they will form overlapping in this fashion. It is said to be sideways overlapping. It is said to be sideways overlapping. So this is all about the overlapping we have. Students, please do remember here, whenever we consider SS overlapping, always remember this is said to be sigma SS bond. Sigma bond. Here also on head-on overlapping we obtain sigma sp bond. Sp sigma bond is formed. But when you consider sideways overlapping of two orbitals, remember it is pi bond. Always pi electron clouds will be participating in the bond formation. So sigma bond and pi bond are of two types. Remember, whenever we have this sigma bond formation, we cannot rotate this molecule freely. There is no free rotation of a molecule is seen in case of sigma bond. Okay, but in case of pi bond, we can rotate these molecules or these orbitals freely. So generally pi electrons are loosely bound than that of the sigma orbitals. So all these things we generally consider in the distinguished part of sigma bond and pi bond. Remember, the distinguish between the sigma bond and pi bond, the differences will be generally asked for your examination for 2 to 3 marks. We need to understand what is sigma bond, what is its characteristic properties. Then we have to understand what are pi bonds, what are their characteristic properties. In detail we need to know, because it is important question, can be asked in the examination. Let's do that one. Before to that, do complete this. We'll move to that one. Welcome dear students. Now let us discuss regarding distinguished points with respect to sigma bond and pi bond. In the previous, that is ಸ್ವಲ್ಪ ಹೊತ್ತಿನ ಮುಂಚೆ ನಾ ಏನು ಹೇಳಿದೆ, ಸಿಗ್ಮಾ ಬಾಂಡ್ ಅನ್ನು ಫ್ರೀ ಆಗಿ ರೊಟೇಟ್ ಮಾಡಕ್ಕೆ ಬರಂಗಿಲ್ಲ, ಸಿಗ್ಮಾ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್, ಬಟ್ ಪೈ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಲೌಡ್ ಅನ್ನು ಫ್ರೀ ಆಗಿ ರೊಟೇಟ್ ಮಾಡಬಹುದು. ನೋ, ಇಟ್ ಈಸ್ ರಾಂಗ್. ಸಾರಿ ಫಾರ್ ದಟ್. Generally remember, pi electrons will be overlapping in this fashion, in the sideways. Only certain extent of electron cloud will be touching here. But when you consider sigma bonds, they are symmetrically distributed with respect to their electron cloud. That means electron clouds are symmetrical here. We can rotate the electron cloud and we can also change the position of the atoms. But it is not possible with respect to pi bond, because they are overlapping in this fashion. They are overlapping in this fashion. So free rotation or electron cloud movement generally highly difficult in case of pi bond. It is only sigma bond or sigma electron cloud we can freely rotate, but these pi electrons generally cannot be freely rotated as the direction we want. Okay, this is the point. So this is important point. Do remember, and this is the correct point. Previously mistakenly I spelled like that. Sorry for that. It is the correct one. Now let us begin with the next point, that is sigma overlapping and pi overlapping will form sigma bond and pi bond. Let's see here. As I already explained here, the axial overlapping of atomic orbitals is takes place in sigma bond. See, this is the internuclear axis. So they are axially overlapping. Internuclear axis is going to be overlapping in case of s orbitals or s bond formation. Likewise, we have p bond formation. In case of p bond formation, sideways overlapping of atomic orbitals takes place, as I have shown here. Similarly, coming to the next point, this is as electron cloud are symmetrically distributed, overlapping is interaxial. Remember, this bond is going to be strong bond. This bond, sigma bond, is said to be strong bond. And remember, this is the representation of sigma bond. Like this we will be representing. So sigma bond is considered to be strong bond. And here, as the sideways overlapping is taking place, not complete electron cloud is participating. It is generally weak compared to sigma bond. Pi bond is weaker bond compared to sigma bond. Now next we have here, only in case of sigma bond formation, s orbitals will be involved. S orbital, p orbital, if they combining head on, that is head on overlapping, axial overlapping, then only sigma bond formation takes place. Here s orbitals and only one lobe of p orbital is involved. So what exactly meaning of this one? That is head on overlapping of two s orbitals and head on overlapping of s and one lobe of p is possible. Only these two things are possible, and both the cases we can consider them as sigma bonds only. But in case of pi bonds, only p orbitals are involving. Sideways overlapping of two orbitals, that is p orbitals, will form pi bond. Next one, here electron cloud is uniformly distributed. These are the points I have quoted, not necessary all the points must be written. Based on the marks, on the for which marks they have asked this question, based on that, if it is asking for 3 marks, you are supposed to write the 5 differences. If it is for 2 marks, you are supposed to write 4 differences. At the maximum 4 you are supposed to write it. Next, see here, only sigma bond is going to form here. Head on overlapping of P, S, S, S gives us only sigma bond, right? Here we can form both pi bond and sigma bond. How? See here. If you consider this one, as I already shown here, one of the lobe is involved in the bond, then it is said to be pi. This is sigma bond, right? Sideways overlapping you have seen. In case of sideways overlapping, we can consider pi bond. So in p orbital involvement, both pi and sigma bonds can be formed. Idikkenantarre s orbital, p orbital yenagyavu axially they are overlapping. Axial overlapping ಯಾವಾಗಿರ್ತದೆ ಅದಕ್ಕೆ ಏನಂತಾರ ಸಿಗ್ಮಾ ಬಾಂಡ್. ಇಲ್ಲೇನೈತೆ ನೋಡ್ರಿ ಕೆಳಗಿಂದ sideways overlapping of both the p, ಯಾವಾಗ ಎರಡು p orbital involve ಆಗ್ತಾವ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ ಅದಕ್ಕೆ ಏನಂತಾರ pi bond. Okay, this is the point. Next, see here, as I told you before only, that free rotation is possible in case of s orbitals, but that is sigma bond. In case of pi, free rotation is generally not possible. So these are considered to be most important differences for sigma bond I and pi bond. Do copy these things. We'll move to the next. Okay, dear students, now let's have a discussion on a most important part of the chapter chemical bonding, that is referred as hybridization. First and foremost, I tell you in a layman language or the common day life language, if you consider example for the hybridization, you will be having 2 glasses of juice. You will be having 2 glasses of juice. That is, one glass is of orange juice and the other one is said to be lemon juice. So when you combine these 2 juices present in 2 glasses, I have lemon juice here, I have orange juice here, I have lemon juice here. But when you combine them each other in another glass, you will be having the property of lemon juice as well as orange juice. One kade ಏನು ಹಿಡ್ಕೊಂಡಿರಿ orange juice ಹಿಡ್ಕೊಂಡಿರಿ, ಇನ್ನೊಂದು ಕಡೆ ಗ್ಲಾಸ್ ಒಳಗೆ ಏನು ಹಿಡ್ಕೊಂಡಿರಿ lemon juice ಹಿಡ್ಕೊಂಡಿರಿ. ಓಕೆ, ಎರಡು ಬೇರೆ ಬೇರೆ ಅವು. Orange juice in property na bere, lemon juice in property na bere. If you go on pouring them, ಎರಡನ್ನು ತಗೊಂಡು ಇನ್ನೊಂದು ಏನು ಮಾಡ್ತೀರಿ, ಒಂದು ಗ್ಲಾಸ್ ಒಳಗೆ ಪೋರ್ ಮಾಡ್ತೀರಿ, ಎರಡನ್ನು ಸೇರಿಸಿ ಹಾಕ್ತೀರಿ. ಆವಾಗ ಎರಡು ಕಂಬೈನ್ ಆಗಿ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮಿಕ್ಸಪ್ ಆಗ್ತವೆ ಇಲ್ಲೋ. ಲೆಮನ್ ಜ್ಯೂಸ್ ಇಂದ ಟೇಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ಏನಿತ್ತಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಆರೆಂಜ್ ಜ್ಯೂಸ್ ಇಂದ ಟೇಸ್ಟ್ ಆಮೇಲೆ ಪ್ರಾಪರ್ಟಿ ಜೊತೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮಿಂಗಲ್ ಆಗ್ತೈತಿ. ಹೌದಾ? ನಮ್ಗೆ ಪ್ರಾಪರ್ಟಿ ಎರಡೂದ್ರದ್ದು 50-50% ಬರ್ತೈತಿ. 50% ಈ ಒಂದು ಗ್ಲಾಸ್ ಒಳಗೆ ಎರಡೂ ಮಿಕ್ಸಪ್ ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ 50% ಪ್ರಾಪರ್ಟಿ ಆರೆಂಜ್ ಇರ್ತೈತಿ, 50% ಪ್ರಾಪರ್ಟಿ ಯಾವ್ದ್ರದ್ದು ಇರ್ತೈತಿ, ಲೆಮನ್ ಜ್ಯೂಸಿಂದ ಇರ್ತೈತಿ. ಅದು ಅವಾಗ ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ನಾವು, ದ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ದೀಸ್ ಟೂ, ದಟ್ ಈಸ್ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಬೋತ್ ಜ್ಯೂಸಸ್ ಇನ್ ಒನ್ ಗ್ಲಾಸ್ ಈಸ್ ಸೆಡ್ ಟು ಬಿ ಹೈಬ್ರಿಡ್ ಜ್ಯೂಸ್. ಅದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು, ಹೈಬ್ರಿಡ್ ಜ್ಯೂಸ್ ಅಂತೀವಿ. ಹೌದಾ? So that type of hybridization or hybrid juice, what I told you, is a thing that we generally consider in our day life example. Now, coming to the exact point, that is, if you speak in terms of chemistry, we need to know that intermixing of pure atomic orbitals. Pure atomic orbitals. And one may be having electron cloud in the spherical shape, or the other may have in the other shape. The other atomic orbital. Atomic orbital s orbital ಇರಬೇಕಂತೇನಿಲ್ಲ. s orbital ಆದ್ರೂ ಇರಬಹುದು, ಬೇರೆ orbital ಆದ್ರೂ ಇರಬಹುದು. ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಏನು ತಗೋತೀನಿ, ಒಂದು ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ s orbital ತಗೋತೀನಿ, ಇನ್ನೊಂದು ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ ಏನು ತಗೋತೀನಿ, p orbital. I will be taking p orbital. p may be px, py, or it may be pz also. This is px, this is pz, and this is said to be py. Okay, py, px, pz. ಇವು ಮೂರು ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ ಒಳಗ ಯಾವುದಾದ್ರೂ ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ ಅನ್ನ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಇನ್ವಾಲ್ವ್ ಮಾಡ್ಕೋಬಹುದು. ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಐ ಮೀನ್ ಟು ಸೇ ಡೆಫಿನಿಷನ್ ಏನು ಹೇಳ್ತಿದ್ದಿಲ್ಲೇ ನೋಡ್ರಿ, ಇಂಟರ್ಮಿಕ್ಸಿಂಗ್ ಆಫ್ pure atomic orbitals of slightly different energies and different shapes to give equal number of hybrid orbitals of same energy. ಏನು ಹೇಳ್ತಾರೆ ಅವರು, ಎರಡು ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ಸ್ನ ನಾವು ಮಿಂಗಲ್ ಮಾಡ್ತೀವಿ, ಅಂದ್ರೆ ಇಂಟರ್ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ. ಎರಡು ಆರ್ಬಿಟಲ್ಸ್ ಇಂಟರ್ಮಿಕ್ಸ್ ಆಗುವಂಥ ಆರ್ಬಿಟಲ್ಸ್ ಎರಡರದ್ದು ಶೇಪ್ ಸೇಮ್ ಇರ್ಬೇಕಂತೇನಿಲ್ಲ. ದೇರ್ ಮೇ ಬಿ ಅ ಡಿಫ್ರೆನ್ಸ್, or they may have different energy values also. S orbital in the p orbital in the energy, if you consider, they are entirely different. S orbital is very very close or very near to the nucleus in an atom, will be having high energy than that of the p orbitals. So we need to combine of two different energy orbitals, also those orbitals having different shape also. Before mixing they will be having different energies, different shapes, but after mixing they will have a same energy pattern. That is what the definition of the hybridization is going to defines us. Now this is the definition part we have come to know. So after intermixing they will be having, remember, they will be having identical shape. They will have identical shape as well. They will have same energy. Intermix ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆ s orbital spherical ಕಾಣತಿತ್ತು. After intermixing it will be having different shape after when it get combines with p. Getting what I am telling you? So that is the main thing we need to understand here. Okay, so s electron cloud combine ಆದ್ಮೇಲೆ energy of those orbitals and the shape of the orbitals will become same. ಇಂಟರ್ಮಿಕ್ಸ್ ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆ ಎರಡು ಬೇರೆ 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 ತರ ಇದ್ವು, ನೀ ಬೇರೆ ನಾ ಬೇರೆ ನಾ ಬೇರೆ ನೀ ಬೇರೆ ಅನ್ಕೊಂತ ಅಡ್ಡಾಡ್ತಿದ್ವು. ಒನ್ಸ್ ದೇ ಕಂಬೈನ್ ಈಚ್ ಅದರ್, ಇಂಟರ್ಮಿಕ್ಸ್ ಈಚ್ ಅದರ್, they will ought to have same energy and they will must have same kind of shape or identical shape. This is what the definition says. Now coming to the features. Definition ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಯ್ತಲ್ಲ, very easy it is and it is most important. Once you understand hybridization, next theories we have some of the theories, those will become very easy for you. Coming to the first point of the features, valence shell orbitals of atoms are hybridized. ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಂದ್ರೆ ಏನ್ರಿ, ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್ ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಶೆಲ್ ಏನಿರ್ತದಲ್ಲ, ಆಕ್ಚುಲಿ ದೋಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಇಂಟರ್ಪೆನೆಟೆಡ್. ಇಂಟರ್ಪೆನೆಟ್ರೇಷನ್ಗೆ ಯಾವ ಆರ್ಬಿಟಲ್ಸ್ ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ ನಾವು, ಲಾಸ್ಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಆಫ್ ಆನ್ ಆಟಮ್, ದಟ್ ಈಸ್ ವ್ಯಾಲೆನ್ಸ್ ಆರ್ಬಿಟಲ್ಸ್. Then we have orbitals of almost same energy. Intermixing ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆಗ there will be a slight difference in energy, but almost the same energy ನೇ ಇರ್ತಾವೆ. ಅಂದ್ರೆ phases positive only combine each other to form the bond. They will have a kind of extent of same energy, maximum energy ಇರ್ತದೆ, almost same ಇರ್ತದೆ. Next, excitation of electron is not essential. Excitation of electron is not essential. ಈಗ ನೋಡ್ರಿ, ಯಾವುದೋ ಒಂದು ಆಟಮ್ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಕೆಲವೊಂದು ಆಟಮ್ಸ್ ಒಳಗೆ ಏನಿರ್ತೈತಿ, ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಆರ್ಬಿಟಲ್ಸ್ ಇರ್ತಾವೆ. As well we will be having empty orbitals. As well we have partially filled orbitals. ಕೆಲವೊಂದು ಸಾರಿ ವ್ಯಾಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಕಂಪಲ್ಸರಿ ದೇ ಆರ್ partially filled irtav. Okay, so for hybridization purpose, what the feature is explaining, it is not at all necessary that we must have to have empty orbitals, partially filled orbitals and completely filled. ಮೂರು ಇದ್ರೂ ಕೂಡ ಏನು ಮಾಡ್ಬೋದು ನಾವು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಪ್ರೋಸೆಸ್ ಅನ್ನ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡಬಹುದು. Orbitals having no electrons, orbitals having partially filled electrons, orbitals with empty orbitals, empty electrons ಇಲ್ಲದೆ ಇದ್ರೂ ಕೂಡ ಎಲ್ಲ ರೀತಿಯ ಆರ್ಬಿಟಲ್ಸ್ ಅನ್ನ ನಾವು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಪ್ರೋಸೆಸ್ ಒಳಗ ಇನ್ವಾಲ್ವ್ ಮಾಡ್ಕೋಬಹುದು. ದಟ್ ವಾಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಟೋಲ್ಡ್ ಬೈ ದಿಸ್. Excitation of electron is not essential. Completely filled, partially filled, even empty orbitals can be involved in the hybridization process. This is most important. These 2 points you have to remember. Then after hybridization, they are telling these are the features before hybridization. Once hybridization is done, hybrid orbitals will have 100% equal energy. ಮುಂಚೆ ಏನಿತ್ತು, slightly difference in the energy we have seen. Once they get hybridized, once they intermixed each other, they will ought to have same energy for both the atomic orbitals. This is what the theory part of hybridization process. When we consider some of the examples of hybridization, we will understand these points in detail. These are seems to be very important. Do copy this. We'll go for the example part. Okay, dear students, as I told you, hybridization definition part and the features. We will understand the things in detail with the help of examples. This BeCl to beryllium chloride example we also have considered in case of VSEPR theory, VSE, valence shell electron pair repulsion theory. There you have already considered. Why you have considered here also? Because in this also we will be taking this BeCl2 and we can understand how does hybridization takes place. It is the simple molecule. With the help of this one, if we understand, the other things will become very easy for us. And let's start with discussing the hybridization in BeCl2. So hybridization in BeCl2, let's discuss. Okay, now I have written here first point, sp orbitals are going to be arranged in a linear fashion. What are those sp orbitals? We have beryllium with 4 electrons because atomic number is 4, hydrogen, helium, lithium, beryllium. So it will be having 1s2, 2s2. So electrons are arranged in this fashion, right? What the first point is saying here, the sp orbitals are linearly arranging here. Where is p orbital here? There is no p orbital. Remember or listen to me very properly. Once we have s orbital and we have 2s orbital, definitely we will be having 2p orbital, right? But the thing is, this 2p orbital, what we are considering here, it is empty, right? So now, as it is empty here, we need to provide space for what? Chlorine is coming here because in BeCl2 there are 2 chlorine atoms are present. Chlorine with a 7 valence electron, it needs to combine with a beryllium. So this beryllium now in such a position that it has to give 2 electrons to chlorine. ಯಾವ ತರ ಕೊಡಬೇಕಿದು? ಇದು ನೋಡ್ರಿ, ಇದು ಏನಿದು, ಬೆರಿಲಿಯಂ is a kind of host. ಇದು ಏನಿದು, ಹೋಸ್ಟ್, ಯಾವುದೋ ಒಂದು ಫಂಕ್ಷನ್ ಅನ್ನ ಅರೇಂಜ್ ಮಾಡೈತೆ. ಇದು ಬೆರಿಲಿಯಂ ಫಂಕ್ಷನ್ ಅರೇಂಜ್ ಮಾಡೈತೆ ಅಂದಮೇಲೆ ಯಾರ್ಯಾರು ಗೆಸ್ಟ್ ಬರ್ತಿರ್ತಾರಲ್ಲ, ಗೆಸ್ಟ್ ಅನ್ನ ಸರಿಯಾಗಿ ನೋಡ್ಕೋಬೇಕು, ಗೆಸ್ಟ್ ಉಳ್ಕೊಳ್ಳಿಕ್ಕೆ ಜಾಗ ಕೊಡ್ಬೇಕು, ರೈಟ್? ಸೊ ಇದು ಏನ್ ಮಾಡ್ತೈತಿ, ಬೆರಿಲಿಯಂ ಈಗ ಇದ್ರ ಕಡೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ 1s2 ಒಳಗ 2s ಒಳಗ ಅದಾವು, ಹೌದಾ? ಈಗ 2 ಕ್ಲೋರಿನ್ ಬರಾಕತ್ತಾವು. Chlorine 2 atoms are coming. They want space or they want to settle or they want to stay with the beryllium. Beryllium joti stay ಮಾಡಾಕ ಬರ್ಲಿಕ್ಕದವು because it is invited. Function ಗೆ beryllium invite ಮಾಡಾತೈತಿ. If those 2 are coming means those 2 electrons must have place here. Those 2 chlorine atoms must have place to accommodate here, right? ಇವಾಗ ಬೆರಿಲಿಯಂ ಏನ್ ಮಾಡ್ತೈತಿ, ಕ್ಲೋರಿನ್ ಬರಾತ ಅಂದ್ಮೇಲೆ ಎಲ್ಲ ರೆಡಿ ಮಾಡ್ಕೋತೈತಿ. 2s2 ಒಳಗ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದನ್ನ ಏನು ಮಾಡ್ತೈತಿ ಶಿಫ್ಟ್ ಮಾಡ್ತೈತಿ. ಯಾವುದಕ್ಕೆ ಶಿಫ್ಟ್ ಮಾಡ್ತೈತಿ 2p ಆರ್ಬಿಟಲ್ಗೆ ಶಿಫ್ಟ್ ಮಾಡ್ತೈತಿ. Shift ಮಾಡಿದ ತಕ್ಷಣ what is the hybrid? These two we are not going to consider because these two electrons are closely associated with the nucleus. ನೋಡ್ರಿ ಇದೇನಿದು ಬೆರಿಲಿಯಂ ಇನ್ ನ್ಯೂಕ್ಲಿಯಸ್. We have first shell ಅಂದ್ರೆ 1s ಒಳಗೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಅದಾವ. Then I have 2s ಒಳಗೆ ಮತ್ತೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಅದಾವ. These 2 electrons of first 1s are closely associated with the nucleus. Nucleus ಏನು ಮಾಡ್ತೈತೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ಕೊಡಂಗಿಲ್ಲ, ಗಟ್ಟಿಯಾಗಿ ಹಿಡ್ಕೊಂಡ್ಬಿಟ್ಟಿರ್ತದೆ, ಬಿಡಂಗೇ ಇಲ್ಲ ಅದು. Okay, so only these 2s2 electrons can participate in a bonding. See here, what will happen? Beryllium will give one of the electron to the 2p. Then what will happen the configuration? See here, it has got 1 electron left and p has got 1 electron in px due to excitation of electron. Once this excitation is done here, now these 2 orbitals, that is s orbital and p orbital, will be intermixed. What is hybridization? Intermixing of atomic orbitals. What are the atomic orbitals we are intermixing here? We are intermixing s orbital and p orbital. So see here, this s orbital, atomic orbital intermix with p orbital. They will arrange in such a manner that sp they will form. See here, I have shown. This is one of the electron from beryllium. It is been excited. Intermixing of these 2 atomic orbitals happens and they will form sp type of combination. Sp type of combination. Getting what I am telling you? Now 2 electrons are coming. These 2 electrons will be get combined with beryllium. So how does that combination or the bonding takes place? See here. Now after intermixing we have beryllium at the center. Okay, it was having s orbital as well as it was having p orbital. After it intermixing, it will be seems to be like this. It seems to be like this. Fine. So this is beryllium molecule. We know that chlorine coming to be p block element, it will be having p orbitals. So one chlorine will come and attach here in this fashion, and similarly another chlorine will come and attach in this fashion. So now this is said to be a linear molecule. Linear combination takes place. It is said to be linear molecule. See how to show this one. Be Cl. The bond angle seems to be 180 degree. This is linear molecule. Right? Understanding? So what are the orbitals are involved? S orbital and p orbital are involved. There are 2 electrons are coming here for bonding purpose. And at last we will be showing the bond formed between beryllium and chlorine like this. So this is all about BeCl2 hybridization part. And one more point I have to tell here. After combination of s orbital and p orbital, there is only 1 electron in the p and only 1 electron in s after excitation, right? 1 electron in s and p. So S is also participating 100%, P is also participating 100%. When they together, they combine each other, they intermix each other. S character is coming here 50%, P character also is coming here 50%. So S character is 50% and P character is 50% here. So now remaining Py and Pz unhybrid orbitals lie perpendicular to plane of the sp orbital. sp orbital ಆದ್ಮೇಲೆ hybridization ಆದ್ಮೇಲೆ we will be having py and pz orbitals left. We will be having 2 types of orbitals, right? So if you consider this is x axis, this is y axis, this is z axis, we will be having orbitals like this. These are p orbitals, right? And we will be having like this, right? Now what we have involved here, what type of orbital we had considered here? We had considered x axis orbital. Now y and z will be remaining as it is in this molecule. We will be not showing that one because only x axis px is involved here. That is the second point. The remaining are unhybridized and they will be lying perpendicular to the sp orbital. This is sp, they will be lying perpendicular like this. So this is all about the hybridization in case of beryllium chloride, BeCl2. Please do copy this point. We'll move to next.